Okay, hopefully we are live. I am trying to monitor this from a couple sources here. I'm gonna give it a shot. So if I've got decent internet. I'm connected with a wired connection here, so not relying on the Wi-Fi, but in the past I've had issues, so we'll see what happens today. Um, Going to try to switch over here. I've got a couple topics here that I want to go through. Starting out here mostly with a couple of presentations. This is going to really focus on the order of operations today, and just some really simple mathematics problems based around that. And depending on how it goes in the future, I may do some more mathematics content. The channel's kind of evolved a little bit away from that, but I still like to come back and do some of this. Well, let's see if we can switch over to the next scene and away from OBS Studio. All right, we're going to give this a shot. So, double check the screen here and we will get started here shortly. Yeah, you can probably see the OBS screen there popped up initially. I'm using OBS Studio in an attempt to do some of the streaming, and there's a little bit of a delay. I've got a monitoring system set up, so I apologize for that. But the first thing I wanted to do is cover this order of operations convention that you see. A lot of problems show up on Facebook related to this. So basically, you may have heard of the order of operations convention. It's a convention that allows people to solve for the same answer to mathematics problems, regardless of where they are in the world. All right. Then the origins of this convention, at least in Western civilization, it can be traced all the way back to the 16th century. So we're really talking about the 1500s as far as that goes. And there's a lot of people who understand this, but then a lot of people believe that this order of operations is some kind of random and made up thing, or it's arbitrary. I see a lot of comments from people who believe that, and it's really, I think, because they don't understand the relationship between multiplication, division, addition, and subtraction. Now there are some acronyms out there, such as PEMDAS, BODMAS, BEDMAS, BIDMAS. They all really mean the same thing, but if you live in an English-speaking country, sometimes the terms are given different names, but they really all give the same answer. But even these acronyms can be a little bit misleading. I know in North America, the most common one used here is PEMDAS, which represents parentheses, exponents, multiplication, division, addition, and subtraction. A lot of people get confused with this because they believe that it's a six-step checklist. But the truth is that multiplication and division have equal precedence. So it could have been written PEMDAS or PEDMAS. Um, Division is just multiplying by a reciprocal. So when you're looking at a problem and solving it, you solve multiplication and division left to right in the order that you find them. All right, so let's see here. And the same with addition and subtraction. I might have forgotten to cover that as well. That also is solved left to right. So let me see how we're doing here on the stream so far. All right, hopefully we are getting our sound working. If not, let me know. I believe it is working. I just checked my monitor, but you let me know in the comments as we go through this. Well, I wanted to solve a few different problems today. We're going to get into that. I did mention here, getting back to the order of operations, I don't want to get too far off topic, but as I said, multiplication and division have equal precedence. Division is simply multiplying by a reciprocal. So that's why when you see PEMDAS or BODMAS or any of these acronyms, um, PEMDAS is not telling us that multiplication must be done before division. BODMAS is not telling us division must be done before multiplication. It's just an acronym. It's a memory tool, but it's not to be misinterpreted as a six-step checklist. For example, here, you can say 10 divided by 5 is 2, or you could say 10 multiplied by 1/5 equals 2. So once again, division is just the same as multiplying by a reciprocal. And then keep in mind, too, when you're thinking of the order of operations, there's this property known as the associative property, okay? It applies to addition, but not subtraction. So addition and subtraction are equal, but and you can do addition and subtraction in any order, but what I often find is that people move the signs to the different numbers. And what I mean by that is, for addition, 6 plus 2 is 8. 2 plus 6 is 8. Let's get a cursor on that, or pointer. 2 plus 6 is 8. But here, what I see people doing a lot, is notice that this is a positive 6. 6 minus 2. Positive 6 minus 2 is 4. But 2 minus 6 is equal to negative 4. So you cannot just swap these numbers around when you're dealing with when you have addition and subtraction. And I see people do that a lot. People will say, well, you have to do adding before subtracting because they think that PEMDAS and BODMAS is telling them to do that. You can't move the negative sign from this 6, and you can't move the positive 6 here and make it negative down here. You can see this is positive 6, this is negative 6, minus 6. So there is a difference. It's not the same thing. Subtraction is the addition of a negative number. So as I said, addition and subtraction have equal precedence. 6 minus 2 is 4. 6 plus minus 2 is 4. 6 plus negative 2 is 4. All right, same thing. Keep in mind, and I've said this a lot in other videos, multiplication is shorthand for addition. So 5 times 4 is the same thing as adding 4 5 times. Oh, I'm sorry. It's, well, actually 5 times 4 would be better represented as saying you're adding 5 4 times. All right, so this is a little backwards how I have it written out here. 4 times 5 should be the same thing as adding 4 5 times. But regardless, however you look at it, whether it's 5 times 4 or 4 times 5, the answer would be 20. So which way is it easier to write? It's easier to write 4 times 5 or 5 times 4 than it is to write a whole bunch of addition, right? So that's really what it is. Multiplication is just shorthand for addition. So that's actually why it's given precedence over addition or subtraction. And that is true even without parentheses. I'll get into that a little bit later. All right, there is also the associative property applies to multiplication. In other words, you can rearrange these numbers any way you want. You're still going to get the answer of 30. 3 times 2 times 5 is 30, because 3 times 2 is 6, 6 times 5 is 30, 5 times 2 is 10, 10 times 3 is 30, 2 times 3 is 6, and then multiplied by 5 gives you 30. So the numbers can be switched. Now, the associative property does not apply to division. You cannot say 10 divided by 5 is 2, and then turn around and say 5 divided by 10 is 2. No, 5 divided by 10 is 1/2. So again, not the same. So with subtraction and division, the associative property doesn't apply. So back to this whole concept about the order of operations being some crazy made-up thing. It's true that the order of operations convention is a convention and not a rule, but that doesn't make it arbitrary, and it does not mean that you can ignore it. So many people have a poor understanding of what a convention means. Some people will say, well, it's a convention, so that means I can just do whatever I want. Well, a convention really is saying that people have come together and agreed to a set of standards. And with the order of operations, this goes way, way back. I mean, we're talking back into the 1500s, at least in Western civilization. Now, there are some ambiguities that we'll get into a little later, but this is a pretty solid convention. Nobody was taught to blindly solve left to right at any time. Now there is a slight exception that I learned about. There's a couple teachers out of Canada who brought this one up in a text that I was reading. But the order of operations is it's basically universal. There's an exception in Kenya where I believe, and I don't know if this is still true today, but students there had been taught to solve division before multiplication. So actually, when they're looking at something, and I don't even know if they use the acronym BODMAS, but they were taught division before multiplication. But the thing to note is if you understand how multiplication and division work, you're going to find out that you'll get the same answer if you always do the division before multiplication. And you're going to get the same answer as if you were using PEMDAS or BODMAS, the traditional order of operations. You're going to get the same answer. So I just wanted to bring that up too, because a lot of people try to claim, well, back in my day we didn't learn that. Well, um, there's no textbooks. I mean, it's an agreed upon standard. Every textbook written in this century and before that has really followed the order of operations. Um, so again, what is that order of operations convention? Well, if we're looking at PEMDAS, it's parentheses. Now, if you've got BODMAS, BEDMAS, BIDMAS, they instead of parentheses, they just refer to them as brackets. And then for PEMDAS, you have exponents. Now, with BODMAS, they call them orders. Orders is kind of a more generic term, and actually I like that one better because exponents, we all know what that is. 5 to the second power is the same as 5 times 5, or 25. Well, the step number 2 is really dealing with anything that is shorthand for repeated multiplication, which could be your exponents, it could be square roots, could be factorials. So exponents is a little bit too restrictive in the way that it's mentioned here. You really should have orders is a little bit better term. There's BIDMAS as well. I don't recall exactly where that's used. Indices and so on. Multiplication and division, left to right, step number 3, and then 4, addition and subtraction. And again, I wrote it left to right. Honestly, addition and subtraction can be done in any order, but as I mentioned before, you cannot put the sign, move the minus sign to a different number. Now, and some remember the order of operations by these acronyms that I just mentioned, but they all represent the same 4 steps. That's a point of confusion. Some learned it through a mnemonic, like please excuse my dear Aunt Sally. Still the same 4 steps. So the order of operations is logical. It's far from arbitrary. Again, multiplication is repeated division. Division is multiplication by a reciprocal. Exponents are just another way of writing repeated multiplication. So that would be why your exponents have higher priority than multiplication. That's why exponents have higher precedence than division. That's why factorials have higher precedence. Factorials is another shorthand way of writing repeated multiplication. Um, and parentheses, I see a lot of people say, well, you ignore the order of operations and you just go left to right if you don't have any parentheses or brackets. Well, parentheses and brackets are nothing more than grouping symbols, and the items inside of them have to be solved according to the order of operations, which again is your exponents, multiplication and division, and addition and subtraction. So parentheses is just saying we want you to um, give higher priority to what is inside of these parentheses or brackets, but they don't give multiplication higher priority than addition. Multiplication by default already has higher priority. And again, this whole idea of arbitrary, a number line is arbitrary, right? Um, if somebody designed a number line, we could have easily have all agreed and said, hey, we want the positive numbers all written to the left, like down here, and all the negative numbers to the right. But by convention, we decided, no, we want the negative numbers going to the left, and the positive number is going to the right. That's arbitrary, okay? There's no reason for it. The order of operations is based on the relationship between multiplication and division, addition and subtraction. So it's pretty clear. Now, a lot of people also will make this mistake. They'll argue and they'll post a link to some video about ambiguities in some problems, or how a lot of people hate PEMDAS and BODMAS. And personally, I don't like PEMDAS and BODMAS. I don't like the acronyms because every time I get into a discussion, somebody treats it like it's a 6-step checklist because they memorize the order of 6 letters alphabetically. Well, not alphabetically. They memorize the order of the 6 letters left to right, but they don't understand the order of operations. Now, again, like I mentioned before, there are ambiguities. We'll get into that, things like implicit multiplication and how that's been used in history, but um, there's a lot of problems with people misunderstanding these 6-letter acronyms, which is one reason why I don't really like them. I'd rather have people understand the relationship between all the different operations. And then going forward, you guys should have no issues. If you've got issues with any of these problems, I would say going forward you shouldn't have any. It's never been left to right with mixed operations, okay? I see that argument a lot. People will say, well, back in my day in the 60s, back in my day in the 70s, back in my day in the 80s. No, it was never been left to right. If you have a problem like this, you have 3 plus 3 times 3 plus 3 equals what? All right, well, a lot of people will say, gee, you add 3 plus 3 and get 6, and multiply that by 3, you get 18. Then 18 plus 3 is 21. The answer is 21. Well, it's not 21, okay? Multiplication has precedence over addition. We've already gone through this, right? The parentheses, the exponents, multiplication and division, addition and subtraction. Well, we've got multiplication here, and I know people will say, well, if it was supposed to be that way, you'd write the multiplication first. Well, that's not true either. Multiplication has precedence regardless of where it is in the expression or the equation. So 3 times 3, and again, if that confuses you, just replace the multiplication with equivalent addition. 3 times 3 is the same as 3 plus 3 plus 3. So there's no difference between writing it this way or writing it this way, right? So if you convert the multiplication over to addition, you're still going to get the answer of 15, just as you would if you take 3 times 3 is 9, 9 plus 3 is 12, 12 plus 3 would give you 15. So it's the same thing. And again, it does not matter where the multiplication is in the problem. Here it's in the middle, here it's at the front, here it's at the end. All of these give the same answer of 15, because no matter what, you need to solve the multiplication before the addition. And it's always been that way. I know some people haven't done this kind of mathematics, they haven't done this kind of arithmetic for a long time, and I get it, but this is how it's always been. All right, so a lot of these puzzles that you'll see, like that we're going to talk about a few of these problems, some of the problems on Facebook, they'll always have a got you in these problems, such as a lack of parentheses, and a lot of times that puts people into a fit, and they just don't remember how the order of operations works after all these years. But it's kind of hard for people to admit that they're wrong about what they were taught. And I really, there's no way, unless your teacher has ignored every textbook that was ever written, because there's no textbooks out there that said, well, if you don't have parentheses, you just go left to right. Now, I can see where a teacher might say, well, go ahead and put parentheses around the multiplication to remind you that you need to do that first. I could see that happening. And I think that's where some people are confused in their memory of how this works. But you look at one of the things I always like to bring up is the formula for the area of a circle. The ancient civilizations, including the Egyptians and Babylonians, they all had accurate approximations for pi, that they used in a lot of practical applications. Now, you can see from the formula for the area of a circle that you don't multiply pi by the radius and then, square, you don't square the result of that, right? There's no parentheses in a equals pi r squared. And yet you do not multiply pi times r and then square that. You actually solve r squared first and then multiply that by pi. So there's no difference. Whenever you see this formula, it's always written a area equals pi times the radius squared. So a equals pi r squared is identical to r squared pi, or r squared times pi. Same thing. It's a pretty old formula, right? So again, a equals pi r squared is the same as pi times r, because remember what exponents are, right? Exponents is a shorthanded way of writing repeated multiplication. So exponents has priority over multiplication, and you don't see any parentheses, you don't see any brackets here, right? But again, exponents have precedence over multiplication. So right here in the formula for the area of a circle, you're dealing with the order of operations, whether you know it or not. Now, there's a lot of examples out there. You see a lot of these popular problems online. We're going to start getting into just solving a few of these now that we've kind of spent a lot of time just going over the order of operations. I didn't really expect to spend 20 minutes on that topic, so I apologize if I've bored anyone already. But one of these problems here is 50 plus 10 times 0 plus 7 plus 2. And now I will see a lot of answers for this problem, either 9 or 69, are two of the most common incorrect answers that I've ever seen for this problem. So it's not 9 and it's not 69 either, okay? This one here, 5 plus 5 times 5 plus 5. The correct answer here is, again, multiplication first. So 5 plus 25 is 30. 30 plus 5 is 35. The answer here is not 35, okay? It is not 35. I mean, it's not 55, I'm sorry. The answer is 35. Here's another one that I've seen a lot online. It's 2 times 1 plus 6 times 6 equals what? Well, this one's pretty easy too. You do the multiplication first. 2 times 1 is 2. 6 times 6 is 36. 2 plus 36 is 38. Again, the answer is not 48. I will see a lot of people answer 48 to this one. Another one here, you've got 4 times 3 plus 5 times 2 plus 9 times 6. All right, well, that's equivalent to 12 plus 10 plus 54, which then equals 76. All right, so another way of trying to go after this fallacy, because a lot of people are pretty determined that that they were taught left to right, but I guarantee you that wasn't taught that way. So the fallacy here is that the left to right method is one way to expose that is that when you try to legitimately rearrange the multiplication of the problem, you're going to get different answers going left to right. So you have to think a little bit about how a cash register works, and we'll talk about that too. But here, if you've got this problem and I rearrange the multiplication around, you're going to see 5. If I put the 5 times 2 here, and the 4 times 3, and the 9 times 6, I'm still going to get the answer of 76, right? Because of the order of operations. It doesn't matter what order I rearrange these in. As long as it's 5 times 2, as long as it's 9 times 6, and as long as it's 4 times 3, it doesn't matter in which order I put those and then add them up. Now, it does matter. I can't just take 2 times 9 because there's a plus sign here. All right, I'm not saying that. You can rearrange the multiplication and still get the same answer. But as soon as you change the problem and discuss this using money, sometimes it'll trigger a memory in some people. of how this is supposed to work. I could easily say, hey, I bought four Diet Cokes for $3 a piece, and I bought five iced teas for $2 a piece, and then 9 cheeseburgers for $6 a piece. How much money did I spend? Well, I spent $76, right? Because how do I describe what I just said in mathematics? Well, 4 times 3 plus 5 times 2 plus 9 times 6 is 12 plus 10 plus 54 equals 76. I spent $76. Now, the poor souls who do not remember the order of operations left the restaurant and would have paid $258 if they tried to do the math this way, believing that it was blindly solved left to right. So you can't get the same answer when you blindly solve left to right when you rearrange the multiplication as I just did in that last problem. So, and ask yourself, you got to ask yourself the question, what competent mathematics teacher would have ever taught you that? And the truth is, really, none of them ever did. I mean, you would have to have somebody who really deserved to be fired to have ever taught you that because they would have had to ignore all the textbooks. So, it's perfectly valid to move the multiplication as I just did and still get the answer of 76 over and over. If you use that shopping example I just explained, it doesn't matter what order I might buy those Cokes, the iced teas, and the cheeseburgers, right? It doesn't matter what order. When I take them up to the register and scan them, does it matter if I order the cheeseburgers before the iced teas? They ring them up different in a different order. You're going to spend the same amount of money. Yeah, as long as you bought the same quantities and the prices didn't change. But there are people that will still try to make you believe that their teachers would make you spend more money if you bought the burgers on Monday and the Cokes on Tuesday and the iced teas on Wednesday. Um, than if you bought them on, bought the iced teas on Monday and the Cokes and burgers on Tuesday. So a lot of people aren't really seeing the fallacy of their own argument when they believe that you ever would solve something like that left to right. It's really just kind of a matter of throwing their teachers under the bus, as much as they like to argue that. But oh yeah, and then you get the responses too. Back in my day, the answer was X. When I went to school, the answer would have been blah. Before all this new math, the answer would have been whatever. The answer is something using the old math that I learned. So I've kind of been through this stuff before. I see it all the time, and I'll still continue to see it. A lot of people, they're just kind of belligerent about it, and I'm hoping that people who forgot actually are going to look at this and kind of try to remember how it really works, and if you're just adding and subtracting numbers in your checkbook, maybe you don't deal with mixing operations that much, but this is really how it's always worked. This is, like again, this is not Common Core. This goes back centuries. Um, so yeah, we're gonna kind of get out of that one for right now, guys. And I'd like to kind of move on to working out a couple of problems. So we're gonna look at this one here, actually. I like this one. This is a good one. This one's one that I've seen recently online. So hopefully what I've covered so far is making some sense. Here's the problem. 4 times 4 plus 4 times 4. And what does that equal to? All right, well, if you remember all the concepts we just discussed here, um, you could pause the video if you want to try to solve it. We are kind of live right now, so I'm planning on just going right into it. But go ahead and give it a shot in your head and see if you got it. All right, so again, like we said before, we do the multiplication first, okay? So it's 4 times 4 is 16, and then this 4 times 4 is 16. 16 plus 16 is 32. And I mentioned before that multiplication is repeated addition, so you could replace these two sets of multiplication. 4 times 4 is the same as adding 4 times. All right, so I replace this one with adding 4 times. I replace this multiplication with adding 4 times. And I put in these parentheses just to highlight that it does not change the problem. This is all addition straight across, left to right. You add these all up. You're adding 4 8 times. That's still equal to 32. All right? Does not change the problem at all. Now, I see a lot of people make these mistakes too with calculators that they use. All right, for example, this is a calculator off of a Windows computer. Now, if you use that in standard mode, what you're going to wind up with is you're going to wind up with the wrong answer because in standard mode with the calculator on a computer, it works in what's called immediate execution mode. And a lot of your cheap dollar store calculators work the same way. If you have a really cheapo calculator, they're really only capable of doing um, simple adding, subtracting, maybe multiplying one number by another, that kind of thing. But when you have a long expression with mixed operations, it's solving each operation immediately. So when you have that type of a calculator, you actually need to know the order of operations, and you would have to do your multiplication first with that type of a calculator and enter it correctly. You have to enter the problem according to the order the operations need to be done, not in the order that it's written. All right, and that's not true. If you have that calculator in scientific mode, you'll notice here how everything is entered in correctly. It's not correct here because it's solving every operation as you enter it. And if you don't believe me, try it. If you have a computer, try these two different modes. You click on this, I think they call this the hamburger icon, but you click on that, you can switch between standard and scientific. The correct answer again is 32. So be very careful on your calculators. All right. Let's see, what another problem that we've got here? Oh yeah, here's another good one. Um, this one here, this is only addition and subtraction, okay? This is add this up. Add this, 5 plus 5 plus 5 minus 5 minus 5. I apologize, that's kind of a weird looking minus sign here, but what does that equal to? Okay, well, we won't pause it on this case, but it's very simple, but I'm a little bit embarrassed about posting it, but a lot of people were they thought they were fooled and they claim the answer was 15, okay? And what they did here is they've added 5 plus 5 plus 5 and they got 15. And then somehow they just eliminated these two, which does not make any sense because you have to subtract 5 and then subtract 5 again. The answer is definitely not 15. The problem, and I think what they thought is they thought that the problem, when it says add this, they assumed the problem meant to only add positive terms. Well, it doesn't say that at all. And they thought you just ignored the minus the subtracted parts. Subtraction is the same thing as adding a negative number. You add positive terms and negative terms unless you're told otherwise. Add this says nothing about only adding positive terms. You would also add the negative terms. So yeah, that does not make any sense whatsoever. So just wanted to throw that quick one out there too. Basically that answer would be, 5 plus 5 plus 5 is 15. 15 minus 5 is 10. 10 minus 5 is 5. So really that should be 5. All right, so we got that one. Here's another one. Yeah, this one here. This one here, I see this one posted quite a bit on Facebook, actually, guys. It's 50 plus 10 times 0 plus 7 plus 2 equals what? All right. So with this one here, again, multiplication has precedence over addition and subtraction as far as that goes. 10 times 0 is 0. And oh boy, does this one cause issues. I see a lot of people saying, well, if I have 10 oranges and I multiply them by 0, I still have my 10 oranges. So I will actually see a lot of people assume that this is 10. 10 times 0 is 10. It is not 10, okay? You do not understand multiplication by 0. It's 50 plus 0 plus 7 plus 2 is 59. All right, order of operations again. We already talked about this. BODMAS, BIDMAS, PEMDAS. Yeah. All right, we've covered that one. 59 is the only answer. No other answer is correct. So nobody was taught again to blindly solve left to right. Parentheses are just the grouping symbols. You got the next step, exponents, factorials, square roots um, are equivalent. You've got they're equivalent to shorthand for repeated multiplication. Then you've got your multiplication, shorthand for repeated addition. Division is the same thing as multiplying by a reciprocal. Subtraction is the same as adding a negative number. So it's really how we come up with the order of operations. 9 is a common wrong answer that people get for this problem, okay? To get 9, you would actually have to add parentheses that don't exist. You would have to put parentheses around the 50 plus 10, and then in that way you would add 50 plus 10 and get 60. Then it would be 60 times 0 is 0. 0 plus 7 plus 2 would be 9. But as it is written, the answer is 59, okay? Um, and again, parentheses around multiplication is redundant and it's unnecessary. You can put it there if you want to, and I could imagine that some teachers might say, put them around, write the problem out this way, but then have the students put them around the multiplication, which is fine. There's no difference between this and this. Multiplication still has precedence over addition. But again, they're not needed. Multiplication still has precedence even without them. Parentheses. Now, and it does matter where parentheses get placed on lower precedence operations. If you start putting parentheses around, say, the 0 plus 7, well, gee, that changes the problem completely, right? That changes it altogether. So you can't just put them anywhere. 69, again, is a very common incorrect answer. And I mentioned that example about people saying, well, if I have 10 oranges, multiply them by 0, I still have my 10 oranges. Well, what they just described there is 10 plus 0. They're confusing addition and multiplication. Everyone adding 50 plus 0 in a problem like this is doing it wrong, right? Even if you were blindly solving left to right, 60 times 0 is the same thing as adding 60 um, 0 times, or 0 times 60 is the same thing as adding 0 60 times. No matter how many times you add zeros, you get 0. Um, you multiply 10 times 0, it's multiplication. Okay, 10 times 0 cannot equal 10 if 10 times 1 equals 10, right? 10 times 1 is 10, so how on earth could 10 times 0 be 10? Multiplication has to do with how many groups of things you have. If I have 10 oranges and I put them in one bag, how many oranges did I put in a bag? 10. Because 10 times 1 is 10. 10 oranges are in a bag. If I have 10 oranges and I put them in 0 bags, I have 10 oranges, but I do not put them in a bag, how many oranges have I put into a bag? 10 times 0 is 0. I put 0 oranges into a bag. That's what multiplication is. It's about how many oranges got put into the bag, not about how many oranges I have. So that's where people are really getting confused, okay? Yeah, 60 times 0 is 0. 60 plus 0 is 60. And there's no 60 times 0 even in this problem. 540 is another common incorrect answer here that I've seen a lot. This one's really kind of strange. People will take 50 plus 10 and get 60. Then they're taking 60 times 0, and I guess they're winding up with 60. But what they're doing here is then they've got to be taking 60 times 7 plus 2. They're taking 60 times 7 plus 2, or basically 60 times 9 and getting 540. So this one here is really messed up. And I have seen that one pretty often too, but that is really wrong. All right, so I mean you can go back and look at textbooks. This is from 1913. I think it was William H. Hart, first year algebra. And again, it was algebra. Okay, this is from an algebra book. Does not matter. Okay, does not matter. Then it says right here, the fundamental operations are addition, subtraction, multiplication, and division. Indicated operations are to be performed in the following order. First, all multiplications and divisions in their order from left to right, then all additions and subtractions from left to right. And I can hear it already. People are saying, well, that just tells you that the order of operations only applies to algebra. No, it doesn't. The order of operations applies to algebraic and non-algebraic expressions and equations. It does not matter, okay? I don't know where that came from. The only thing I can think is that, the order of operations showed up in early books on algebra back in the 1500s. So immediately people want to jump on that and say, oh, that's only for algebra. That's totally wrong. Here's a teacher's edition textbook from the 1950s. And again, it has really good examples in here. And it says 5 plus 3 times 2 is 11. All right? It's not 5 plus 3 is 8 and then multiply by 2 and get 16. No. Even back in the 1950s, it was taught this way. It was taught this way way, way, way before, okay? So again, it's not ever been left to right. Here's another problem that we've got. All right, here's a problem. How about 6 plus 6 times 6 minus 6? And I apologize that that has not really a multiplication symbol in there. That looks like an X. But the meaning was supposed to be 6 plus 6 times 6 minus 6. All right, we're going to go through this one as well. All right, we won't worry about pausing on this one. This is really just kind of showing you guys. Again, it's pretty easy to see that if you multiply 6 times 6, you get 36, right? 6 plus 36 is 42. 42 minus 6 is 36. And it's also easy to see, and hopefully a lot of people will see this in their head right away. It's also easy to see that you can cancel the 6 minus 6 out immediately, right? Now, a lot of people get mad at that. I've seen people get angry. You can't do that. You just subtracted before you multiplied. But you've got to think about this. People need to understand how to be efficient and still follow the rules. Canceling the 6 minus 6 out immediately does not violate the order of operations whatsoever. There's nothing wrong with simplifying a problem provided you're not violating the order of operations. Resolving that 6 minus 6 first, even in your head, has zero impact on the order of operations because you know as you're doing this problem, you know that this 6 plus times 6 has to be maintained. And really it doesn't matter what's happening elsewhere here. You can subtract 6 from 6 and then do this multiplication and you still get the same answer. Where people get it wrong is that they go blindly left to right. They try to add these two sixes together, get 12, multiply by 6, get 72, and then what do? 72 minus 6 and get 66. That's where you're going wrong, okay? There's nothing wrong with knowing that you can cancel these out. So, yeah, I wanted to cover that too because a lot of people treat things like PEMDAS and BODMAS as if they're like some kind of mystical chant. They're not magic spells that an incantation that you give. You have to understand. You have to understand what they mean, and you have to understand how not to violate them. All right, but there's nothing wrong with doing it this way. All right, we've covered all that stuff with BIDMAS, BODMAS, all that fun stuff. Let's see. I do have, yeah, we'll get into this one, I guess. Okay, this one You see, this is the one where you'll see a lot of disagreement and argument, and I'll get into this one. All right, so we have 60 divided by 2. And then again, for anyone that might have forgotten, this is implicit multiplication. Whenever you see a number outside of parentheses, it's implying multiplication. It would be the same thing as having 2 and then a multiplication symbol, okay? So it's 2 multiplied by the quantity 3 plus 7 is what that would be. All right, so if you're following the order of operations, the way that PEMDAS and BODMAS are taught, we're taught to say, okay, we need to solve everything inside of the parentheses first. So if you're following that, 3 plus 7 is 10, right? It makes sense. This looks good so far. 60 divided by 2 multiplied by 10 equals what? And this is kind of where this one goes off the rails with some people. And this is where some of the disagreements begin. If you're looking at PEMDAS or BODMAS, you understand that multiplication and division have precedence over addition. And multiplication and division also have equal precedence, and they're solved left to right. So following that convention, you would actually solve 60 divided by 2 first. And the reason for that is because the division is left of the multiplication. Now we're gonna get into this a little bit more because there is some controversy here. But 60 divided by 2 is 30, and what's 30 times 10? Again, this is implicit multiplication. So it's 30 times 10, right? 30 times 10 is what? 30 times 10 is 300. So following PEMDAS and BODMAS, yeah, the answer is, well, before following any of these, BOMDAS, BEDMAS, BIDMAS, PEDMAS, the answer would be 300. And again, like with PEMDAS, it's parentheses, exponents, multiplication, and division going left to right, right? And then addition and subtraction. You've got, again, there's your parentheses. You've got, there's no exponents in this problem at all. And then again, what do we have first again? I said that the division was the furthest left, so we're doing division first. In this case, going left to right. Then we have, we did the divisions, we get 30. Then we have multiplication that we're left with, 30 times 10. All right, 30 times 10 is 300. We don't have any addition or subtraction here. Now, many people get confused over PEMDAS and BODMAS. I already mentioned that they're not a six-step checklist. None of these are a six-step checklist. A lot of people will falsely think that multiplication comes before division because of the order of the letters in PEMDAS and so on. Exponents, again, shorthand for repeated multiplication. Multiplication, shorthand. Again, division equivalent to multiplication by a reciprocal, and so on. So we've covered that if you've been following along, all these different points about the order of operations. Okay, don't need to go through and repeat that. But why does this problem become viral? Because there's a lot of people out there that will argue that it's not 300. So why would they argue that it's not 300? Well, there's this thing called implicit multiplication by juxtaposition. Okay, it's not that common. It's implicit multiplication by juxtaposition and the PEMDAS and BODMAS method of order of operations. This can create some ambiguities based on mathematical interpretations. And so I'm going to try to explain why these could conflict. So again, implicit multiplication by juxtaposition. Implicit multiplication occurs when you have two quantities are written next to each other without a visible multiplication sign. You know, for example, 2 times it's the same thing. You know, you've got 3 multiplied by 4 plus 5. That means the same thing as 3 times 4 plus 5 with or without a symbol. Now, there is a convention that actually conflicts with multiplication and division. It's quite older. It's an old convention, but this old convention was, well, implicit multiplication is given higher precedence than explicit multiplication or division. And when I mean explicit multiplication, I mean multiplication where you do have a multiplication symbol. All right, and you may run into that in some educational or scientific concepts. So, for example, one of the problems you'll see put out there a lot is the 6 divided by 2 multiplied by the quantity 1 plus 2. Now, there's a couple possible interpretations, but if you're using PEMDAS strictly, the way that PEMDAS is normally taught, and I can tell you this is how it's really taught in North America, that you resolve inside the parentheses first, you get 3, then it becomes 6 divided by 2 multiplied by 3, and you treat 2 times 3 is the same as 2 times 3. But again, with PEMDAS, multiplication and division are equal in precedence. So you go left to right. 6 divided by 2 is 3, and then 3 times 3 is 9. You get 9. But when you give implicit multiplication higher priority, which is common, you'll find scientific texts out there, some mathematical texts, where they'll say you resolve the parentheses. Now you treat 2 times 3 as a single implicit multiplication unit, giving it higher priority over division. So if you're doing that, it's basically the same thing as putting another set of brackets around this 2 times 3, which means you would solve this, and then that leaves you with 6 divided by 6 equals 1. So this problem is super viral. This one, the 6 divided by 2 problem is very, very viral. But why is there a conflict? Well, PEMDAS treats multiplication and division as having equal precedence, and really so does BODMAS and the rest. And so they're evaluated left to right. And implicit multiplication by juxtaposition is sometimes interpreted as having higher precedence than explicit division or multiplication. And that's not expressly addressed at all in PEMDAS, so that's the reason behind that. And you'll actually find calculators. There are calculators out there. They're mostly some older Casio models that that will actually give higher precedence to implicit multiplication. Most don't. I mean, if you've got an Android phone, uh, iPhone, those do not give precedence to explicit multiplication. As a matter of fact, a lot of times when you enter those problems in, they'll add the operator symbol in there for you. They'll actually do that. So I kind of want to end this. This has kind of gone on for a bit, but I wanted to end this again just reviewing some of the common misunderstandings with PEMDAS and BODMAS and what those are. So BODMAS, again, it's represented as brackets, orders, division and multiplication, addition and subtraction. Often people, and this is one that bothers me too, often people will list the O component as of or off. And I don't know why they do that, don't know where that got started. Orders includes exponents, square roots, factorials. Of or off is a meaningless description. Again, I'm not sure why that got started unless it's some attempt at trying to describe powers of, which, okay, powers I sort of understand. Powers is kind of another way of probably describing exponents. But I would love it if somebody could explain where this of came from, because it really makes no sense. It's brackets, orders, division, multiplication, addition, subtraction. All right, and PEMDAS is a different acronym, but it also represents that same order of operations. There's no difference, again, between PEMDAS and BODMAS. It's parentheses, exponents, multiplication and division solved left to right, and then addition and subtraction. And again, addition and subtraction, you're not forced to solve one before the other. And again, with PEMDAS, the thing that I don't really like about it is that when you use E for exponents, it doesn't really tell the whole story either. Exponents refers to things like 5 to the third power, 5 to the third power is the same as 5 times 5 times 5 times 5. All right, let's get a pointer again. All right, which is equal to 125. But that step also, other things that are shorthand for repeated multiplication would be factorials and square roots. So like 5 factorial. You'll see these problems a lot. I'll see these on Facebook where they put an exclamation mark after a number. It's not an excited number, okay? The 5 with an exclamation mark does not mean that the 5 is excited. It means a factorial. A factorial is the same, 5 factorial is the same as 5 times 4 times 3 times 2 times 1, or 120. So 5 factorial is equal to 120. Now the square root of 4 is 2. So factorials and square roots and exponents kind of all fit into that same category. It's really better to remember that relationship between mathematical operations than it is to memorize something like appendus or BODMAS or some mnemonic like please excuse my dear Aunt Sally. Then again, parentheses and brackets are just grouping symbols. They're not a mathematical operation in the way that multiplication, division, addition, and subtraction are. Grouping symbols just tell us how to prioritize the operations inside of them according to the priority of operations, which would be your orders, your multiplication and division, and then your addition and subtraction. Exponents and or orders can be looked at as a shorthand for repeated multiplication. So you've got your grouping symbols on top, you've got your exponents and orders, you've got your multiplication and division, and again, they're solved left to right. And then finally, you end up with your addition and subtraction. All right. So I hope some of this has been helpful. We've gone into quite a bit of detail here over this last almost hour, I guess. But if there are any questions, comments, please put them in the comments here, and hopefully I will try to answer anything. I don't know that I see any in there right now. Otherwise, I'd be happy to try to answer any questions that anybody might have. But I think I don't really see any questions in here now, but you are able to comment after the fact. So this live currently, but this will go up on the channel, and feel free to put any comments in there about your understanding of the order of operations or any questions that you might have. And glad that you could all stop by, and hope to see you guys